recording. So you have learned about hashing fundamentals and then the applications, basic areas, and then the collision resolution mainly. Now the final step is, of course, coding is most important though, whatever you know, but you have time to do that. But the moment you get the clarity about these three areas, then you can play a lot. I'll show you the reason of this 3 sessions in just a few minutes because I have gone through lead code. There are 600 plus problems are available on hashing. Let me show you that. Do you really think you have enough time to do? 600. But let me show you interview questions first and then come back to applications. I see some students keep doing 300, 200 like that, and then they give up. But I'm telling you, right, it's not like that. It's about the selection of problems. If you select same set of problems and solve 300, 400, no use. You need to select, there are 4 to 5 kinds of problems. If you pick those, then you can able. Mainly mixing hashing with other data structures is what, as an interviewer, we do ask. The reason is we would like to see how much depth do you have on data structures and algorithms, and how can you apply. See 618 in the lead code. 618, you can see this link, right? Yeah, 618, when do you solve? Even if you take difficulty wise, there will be around, if you take hard and medium, still they will be over 3 to 400. It's hard. So good thing is I did that, and then I put similarly from Geeks for Geeks around 20 plus I picked up, but I picked only 4 out of all. If you solve these 4, you would be kind of able to solve 2 to 400, at least 400 problems. The other 200, I have listed out some more. Some programs, I will keep adding the programs, but I would like to, uh, you know, give scratch your brain on the thought processes. These are other questions with the links available. You can play with these as well. But these are my favorite interview questions. I have asked at least each question 100 times. These 4. It's not mine. My colleagues too, many more. I'll tell you the reason why I picked these questions while we are diving deep into each one. See, this one is not just hashing, it is linking two data structures. So if you see, given two linked lists, find union and intersection. It's easy. Looks like a simple linked list problem. Union looks similar. But remember, union and intersection, the challenge is what? Duplicates, right? So hashing knows whether remember hashing doesn't allow duplicates. Hash table doesn't have any duplicates in computer science. So that's the reason. If you use a C++ inbuilt hash table, you don't need to care. It will return you a false or something wrong with this value when you are trying to insert second time. So use that concept and store first list data into a link hash table. And when you are inserting second list data, if there are any duplicates like this, it will throw false. I can't insert it because it's already available in that address. You understand? When you insert any element, collision happens. And then the hash table will compare. Oh, it's already available. Why should I store it second time? I don't want to.
Yeah.
So that's the, and then store such values in another list that is called intersection. And union means whatever is the end result of hash table is the union. Okay. But many candidates don't answer me. They answer me this. I'll traverse. It is brute force solution. Brute force means I'll traverse the first list and then write another loop. It is like using two nested loops, same as a bubble sort. A loop inside loop, compare brutally first element with all and then store in a new list. What is the time complexity? Multiplication of both the sizes, m into n. M is the first list size, second one is n. Space is always same. You need sum of both to store union values. But this one can be improved by using sorting as well. This is better. At least I can give a chance with second question. This is small question, Rishita. So you will get only 10 minutes to do these kind of questions. These are called brain teasers to see how confident you are. Before we ask trees or some kind of complex questions, this one is kind of brain teaser to see whether you are good with linear arrays and hashing or arrays or linked list before we go with complex topics like trees or dynamic programming or backtracking kind of stuff. Cool. So sorting, this is another fundamental. It is better compared to the other, relatively better, because you need to sort only one time. Once you sort it, that's enough. You can do any number of times the search on other things, union and intersection. But still it is, again, time consuming compared to hashing, because creating a hash table hardly takes you big O of m plus n, because you need to iterate only one element one time. So space and time are same, and it saves a lot of time compared to the other two techniques. I don't specifically expect hashing, but when we give a hint to them, can we use any unique data structures like that? How do you find duplicates without using sortings like that? We keep trying to give hints. If they can't catch, then we'll see. At least if they can answer this sorting properly using quick or merge sort. We don't directly ask you to write a sorting program. We ask you with the problem and see whether you will apply that knowledge or not. You need to do a complete code, clean code, but you hardly have 10 to 15 minutes. That's it. Because another 30 minutes for another question. Better, more complex question. So keep all the answers in mind. Sometimes interviewer doesn't care much about coding. Maybe they'll ask you to write 3-4 lines of core logic. The remaining whole we see is whether you are able to know all the types of solutions, whether you can think more about all these kind of concepts. That's it. Now let's go and see second question. Only 4 questions. Array is subset of another. It is similar like previous one. Array is subset of other means all these elements should be part of this. Okay. Brute force is same as the previous. Go through each and everything through 2 loops and then compare. It takes m into n. Not really scalable. Second is same as previous, sorting. Sort each and then just compare 1, 1, 2, 2, 3, 3, 4, 4 like that. Until you find the first element and then do that. It's still time consuming, sorting and then the comparison. So the third one is hashing. Just to store the long list values in a hash table, largest list. And the second list should be available. If any element is not available, throw error. It's not, throw false. If all are available, throw true. Return true. You got it? You need 2 loops separately. One to store first elements, second to store second elements. Yeah, checking ours. Yeah. When you're storing means it automatically checks. Both are easy, right? Problems look different, but the underlying concept is same. Third one. This is my favorite problem. So if I need to go from Vancouver to Tirupati, it is a place in India, my native. So if I want to go from Vancouver to Tirupati, this is how I came from Tirupati to Vancouver. I think Mumbai it was, but going back. So I need to get this kind of itinerary. Vancouver to Frankfurt, it is in Germany. Frankfurt airport to Delhi or Mumbai. But for now, I have these tickets. Delhi to Chennai, Chennai to Tirupati. This is the way I should go. I don't have a direct flight from Vancouver to Tirupati. At least I should have 3 or 2 layovers. So now, this is the expected output. This is the input. I have 4 flight tickets, but they are randomly arranged. How would you find this? Since you don't know about graphs, I'm not talking about the graph-based solutions. Remember, this question doesn't have anything best or worst solutions. All 3 solutions are perfect. Even if you attempt one, that's good. Usually students always confuse and they feel graphs as a difficult concept. That's why I would like to give you hashing as well. Okay, I don't want to go too deep right now. I'll again come back to this problem once we talk about graphs. Graphs is more easiest compared to hashing, but graph is something which students frequently forget during the interviews. That's why I recommend hashing, because hashing is very easy to remember, but a little bit more coding compared to graph or graph. Both are graphs. These are graph standard algorithms, topological sorting or Eulerian path. But if you forget anything in the algorithm, you're gone in the interview. Rather, even if you forget, it is easy to remember back because it is common thing. How do you do manually? Take each ticket and find the source city. That is the most difficult thing. So how do you find the source city? In this list, if any city is not having a return address, that is the source city. Means you have only going ticket is starting point is there, Vancouver, but it is not repeated anywhere.
Mhm.
Similarly, Tirupati is also not repeated, but you need to see the left side things. That is the source. Destination is the right side thing. If
Yeah.
anything is not repeated in both the places, single time it is available, they are the source and destinations. So 2 parts are over, and then you just need to do a connecting thing. So this is starting point. We identified it is not repeating. And then from here, backtrack to Frankfurt, and then backtrack to Frankfurt to Delhi, right? And then backtrack to Delhi. So you just need 2 hash tables, I can say. There are many ways. 2 hash tables, one for sources, one for destinations. That is one way. Or you can just have a single table and then just do a comparison of strings. So it's up to you whether you need 2 or 1 to store. Or maybe you can use a structure of 2 elements and then store them in a hash table. So you have a lot of ways to do. I'll find a simplest way and then which you can remember easily and then add that code. But my goal here is to give that idea. But see, complexity wise, time and space are, but it is not like so worst. It is more or less same as these algorithms. Many times it is faster. Okay, but you can mention to the interviewer only when collision happens, it will be exponential. But if your algorithm is not having much collisions, then it is fast. Okay. So still space wise, it doesn't take anything extra. It is also equally same as others. But your professors prefer topological or Eulerian. But I'll tell you, your professors don't compare your professor with you in the interview because they keep teaching these algorithms for hundreds of times. But we don't remember, right? That's why I suggest this one to be attempted in the interview. If you give at least idea, interviewer will help you. But
Okay.
graphs, you have to struggle to remember. If you are remembering, if before the interview, if you go through this problem and you have practiced perfectly fine, still attempt that I can have other, interviewer will ask you, do you have other thing than topological? You should say hashing or Eulerian. If you explain all, that's good. If sometimes interviewers don't even ask you to code, they'll ask you to draw through diagram, the algorithm, graph algorithm. If you explain, that's it. If not, that's fine. They'll take care. Uh, they'll ask you to do with your own choice. And finally, when it comes to bus routes, it is opposite to the previous one. In the previous problem, you have only one source, one destination, but multiple flights. But in this problem, you have you have too many sources cycling. In the previous problem, there was no cycle. But in this problem, it is like our Vancouver city buses. Our bus will start from, say, like Surrey, Surrey to Burnaby, Burnaby to downtown, downtown to North Van, and then it comes back to downtown, then Surrey, sorry, Burnaby, and then Surrey. It goes throughout these locations whole day, forever. Now, they will ask you to find a source to destination like this. I want to go from Surrey Central to downtown SFU campus. From Surrey campus to downtown campus. Give me all possible paths, whatever the buses are coming. It is perfectly what Google is doing for you. If you go to Google Maps, bus routes, it gives you a lot of bus routes. You can choose whichever is near available immediately. Same problem. It is not same as previous, but you can use a hash map to store these combinations, unique combinations, and then find either backtracking or other algorithms. Okay, so I will explain this in the next session, but I would like to let you think these are the most important interview questions being asked frequently out of these 600 problems. And if you solve these problems, it is equal to doing 400 plus problems. So I would like to give you introduction, play with these, and one more is there, sorry, it is fifth problem, right? Not fourth. Fifth problems, movie ticket allocation, which I have already explained to you. But see, a lot of problems do not need a hash map. You can still use them using other algorithms, using plain arrays or linked list. But hashing also a way to solve. So in the interview, I have to explain you at least to any one is fine if you do a clean code and complete algorithm. So hashing is enough, but without hashing also, most of these are possible, but do all, present all. So if there is any problem with the code, still interviewer can try to give you hints to correct that, because this mindset is more important than coding, because you don't do coding without looking at the Google or any external sources. Because as an employee, you don't need to buy at anything. You need to take help from other Google or ChatGPT or Gemini or any coding help from other sources and then do the coding. But in the interview, you need to do without looking at those sources. So that's why interviewers know that you don't need to be a good memory person. You should be a good analytical guy or applied oriented person. That's why don't worry too much about implementation. But if this thought process is there, implementation will automatically becomes easy.
Okay.
So this is the movie ticket allocation. Here is the diagram. You can use a lot of algorithms, sweep line or sliding window kind of stuff or any, but underlying to store this two-dimensional matrix, you can either use a 2 by 2 array or a hash map combination of seeds, like you can use, and then use one of these algorithms. Hashing solution by doing this way, or sweep line algorithms, or interval-based approach, many more. But next sessions, I'll go more deep into this based on your, or maybe I'll come back to this after completing the graphs concepts. the core implementations. Meanwhile, I keep adding the programs to those. So see, I have just started implementing these also. You can go through these whenever you're free. And we will come back to these. These are fairly enough to crack a job at Google or Microsoft, Amazon, FANG, anything with 6-digit plus salary at Canada or across or US. Okay. So, but those concepts are fundamentals needed to do. Do you have any doubts before we drop off?
No.
Anything interesting?
Yeah, I'm learning.
I bet you this will save at least 1 to 2 months time for you if you focus on these 5 problems. 2 months of time will be saved. That's what I told to you and your friends. Don't worry too much about lead code or anything. Applied knowledge and concepts are important. That's what for last 16 years I have been seeing. See, when I started coding or when I started getting Amazon or such jobs, I never had lead code at all. Lead code was pretty new by then. So there used to be getting, interviews happening before this website was there. So this this approach is more important than these websites, all this, because they are business. They want you to be a prime member to learn this frequency, all this. That is all trash. It's simply commercial. What's important is, yeah, we should keep an eye, but one big application, end-to-end implementation with line-to-line understanding is what important to save 2 to 3 months of time. Let's do those in the next upcoming sessions. But graphs is important. So for next session, I'll start with graphs and then come back to hashing, or maybe I'll mix both. The reason is uh, many times interviewers switch immediately from hashing to graph. The 30-minute questions are there, right? They're all around graphs. Trees and graphs, they mix those. So that's why we should not limit ourselves to hashing. We will come back to graph and then continuously do the interview problems by mixing either hashing or heap or graphs like that. Okay. That way you will become more confident on data, applying data structures at the same time, real interviews, not just mock or normal. They are the real ones which are proven for decades. Okay. Cool. See you on Wednesday. What time you told?
Can we do before 1:30?
1:30. I'll check my calendar and message you. Mostly
Yeah.
keep it for 12 p.m. around
Okay, that's fine.
12 p.m. But I'll double confirm you mostly by end of the day or tomorrow. But 12
Okay.
p.m. for now. Keep it.
Okay.
Thank you.
Yes.
Bye. See you.
Okay.